If you want to get a finer measurement than you can get with rulers, then a micrometer is a good way of going about this. And how a micrometer works is, this doesn't show the whole thing, but typically it looks kind of like this. You have a spindle and two arms. One of those arms is mounted to the spindle, and how it works is you spin this around. You spin this sleeve. So this part right here is the sleeve that spins. This part right here is mounted to this arm. So what happens when you spin this? What happens when you spin this? I guess this is called the sleeve and that the thimble. When you spin the thimble, what happens is there's a screw that it advances or retreats on, and each full rotation will advance you. In this case, will advance you what, a 1/40th of an inch, I believe. So let's see. Yeah, 40 threads per inch. So that means if you were to spin this thimble all the way around, overall this thimble would move a 40th of an inch. And depending on your location, where you are on that thimble, you can actually get a much more accurate measurement than just by reading a scale like this alone, because then you have not only this scale, but you have where you are in that rotation also that you can read. And where you are in the rotation, you can read off of, you can see there's a scale on the thimble itself. Alright, so in any case, how you go about reading these things, there's actually going to be several different measurements that you have to get. And you can get, it's very, very conceivable that you can get down to the 1,000th of an inch fairly easily using one of these micrometers. So first off, you're going to read the largest number, and the largest number is the number that's available that you can see on the sleeve. It's the one that's fully visible on the sleeve. So in this case, it's a 4. So it's that 4 right there. The 5 is not visible, so we would start the first reading would be a 4, and then within this, let me blow this up because it's a little blurry. So the 4 would be here, the 5 would be here. We can't really see the 5, so it looks to me like the thimble is covering like right here-ish. And so our first reading is the 4. The second reading is figuring out which of these marks were passed. So this would be, this 4 would actually represent 0.4 inches. So there's a decimal place before that. And then we're going to say, okay, well, this is going to be a quarter of the way past this to the 0.5. This is going to be halfway past, and this is going to be 3/4 of the way, or 0.25, or, well, I guess this one represents kind of 0.025, this one's 0.050, and this one's 0.075. So it's a quarter, a half, and 3/4, except the decimal place is moved over a little bit because we're not going from 4 to 5, we're going from 0.4 to 0.5. So the second measurement would end up reading we end up reading 0.025, 0.050, or 0.075. Or, you know, I guess if we're in this region, it would be 0. We wouldn't have any additional amount. So we're going to add those numbers together. So we're going to say, with my example here, this would be 0.4, and we had added on this 0.075. So we have 0.475 so far. Then we're going to measure how far we are along the rotation. And, you know, it's very difficult to tell where we are along there, but fortunately that's what this other scale, this scale right here, represents. Is where we are along there will tell us how what portion of a rotation we've gone. And so you can read off, and how we read this one is this is the line we're using to line up against, and we read where we are on here. So this is 10, 11, 12, 13. And this would be 0.013. So this is the tenths, hundredths, thousandths place. It ends up in the thousandths place there. So we would add these three numbers together: 0.4, 0.075, and 0.013. So we get a 3 here. No, we get an 8. Just kidding. We get an 8 there. We get an 8 here. We get a 4 here. So the total measurement of where this is will be 0.488.